Polar coordinates. Two-dimensional surfaces require two coordinates in order to uniquely specify the position of a point. For example, you should be familiar with Cartesian coordinates, where we have an x-axis and a y-axis, and then we specify the points by looking at how far from this point, called the origin, with coordinates 0, 0, we go to the right or left, and up or down. So this point just here is at 5, 2, because we go 5 to the right and 2 up. This point here is at position 1, negative 3, because we go 1 to the right and 3 down. And this point over here is at negative 4, 1, because from the origin we go 4 to the left and 1 up. All Cartesian coordinates are of the form x, y. So the x number goes first and then the y number. The x-coordinate specifies how far to go right or left from the origin. Going right is positive and left is negative. The y-coordinate specifies how far to go up or down from the origin. Up is positive, down is negative. Another example is latitude and longitude. The latitude is the north or south measurement in degrees from the equator. The longitude is the to the east or west measurement from a line that goes pole to pole called the prime meridian. The prime meridian goes through Greenwich in southeast London. So examples would be Paris, which is at 48.8566 degrees north, 2.3522 degrees east. And Melbourne in Australia, which is 37.8136 degrees south and 144.9631 degrees east. If you and somebody else are at these same coordinates, then you would be close to each other. Note that it's possible for aeroplanes to have exactly the same GPS position and not collide, because they may differ in their height above sea level, something which is known as altitude. But note that that's a third coordinate to move into 3 dimensions. In other words, we have the north or south of the equator, the east or west of the prime meridian, and the height above sea level. Polar coordinates are another way of locating points on a plane, so the same sort of plane where we had Cartesian coordinates. What used to be the positive x-axis is now called L, something called the initial line. Coordinates of points are given in terms of their distance from the origin and their angle to the initial line. The initial line is at 0 degrees or 0 radians. If we look at this diagram, there are 24 rays, meaning those rays are 15 degrees or pi by 12 radians apart. So for this point here, it's at a distance of 10. We can see that from the circle, from the origin. And so its coordinates are 10, and then the angle there would be 30 degrees, or if we were working in radians, 10 and pi by 6 radians. Polar coordinates are always given in the form r theta, where r is the distance from the origin and theta is the angle to the initial line. Note that angles can be given on different domains. A common domain is to go from 0 backwards to here, so that would be negative 180 degrees or negative pi radians, and then go forward 180. The 180 is the one that's usually included. However, in the work we're going to be doing, we're always going to be working with 0 to 360. And when we do that, the 0 is included and the 360 not included. In radians, that would be 0 to 2 pi. Now that we've established that, if we consider this point, we can see its distance is 5. And with 15 degrees for each ray, that turns out to be 165 degrees, or in radians, 5 and 11 pi by 12. This point here, remember we have to go all the way around like that. That one is at 270 degrees, or in radians, that would be 10 and 3 pi by 2.